Good morning, I'm out sick today, so today you're going to complete this notes packet and check your work with the answer key provided in the keys section of Unit 3, and then when you finish, you'll complete the 3.5 homework worksheet. You should be able to complete all of this work by the end of the period and submit it. Let's get started. So yesterday, or last class, we worked on finding the derivative of trig functions using just the trig derivatives as well as the product rule. Today we're going to talk about quotient rule. Now, quotient rule needs to be used whenever there is an x in the numerator and an x in the denominator that can't easily be divided and simplified. With trig functions, that's going to happen often. But the good news is you already know how to do everything you need to do for these questions. So let's get started. First thing you're going to do is break up the numerator and the denominator using whichever letters make you happy. Find each mini derivative. The derivative of 2x plus 1 is 2, and the derivative of sine x is cosine x. After that, you'll go right to the quotient rule. Be careful that the order does matter for quotient rule. So 2 times sine x must go first, and then minus, we have cosine x times 2x plus 1. On the bottom, when we square sine, we're going to write that sine squared x. From there, we can combine our like terms, but first we'll need to distribute. So that will give me 2 sine x minus cosine x times 2x, but I guess we should write that as 2x cosine x, and then minus cosine x. What I did there was took this cosine and distributed it to both of these things, keeping my denominator, sine squared x. Now, at this step, you should look at the numerator. If there is a greatest common factor, you should simplify and take it out and then see if anything cancels. In this particular example, there is no greatest common factor, so this actually is your answer. Please now complete numbers 2 and 3 and then check your work. Pause the video and then we'll begin the next part. So right now you should be doing examples 2 and 3 and checking your work. Welcome back. After doing that, you should now be able to write the equation of a tangent line. This is no different than what we've done in all our other units. So here's what we're going to do. There are 2 things you need in order to write the equation of a tangent line. You need a point and you need a slope. So let's start with the point. The point means you take the x value I give you and plug it directly into the equation that was given. So that would be the tangent of pi over 4 plus the cotangent of pi over 4. Now, this does require the use of the unit circle. Pi over 4 on the unit circle is the point root 2 over 2, root 2 over 2. And tangent is y over x, and cotangent is x over y. So if I work through this example, tangent of pi over 4 would be root 2 over 2 over root 2 over 2, which is 1. Cotangent would be the same, so another 1. Therefore, making the y value of the coordinate point 2. So what we just found is that our coordinate point is pi over 4 comma 2. But in order to write the equation of a tangent line, I also need a slope. Now to find the slope, we first need the derivative. Now the derivative of tangent is secant squared, and the derivative of cotangent is negative cosecant squared x. To get the slope, we now have to sub in our x value. So plug in pi over 4 to the derivative. Now when you see secant squared, this means the secant of pi over 4 squared. And this one means the cosecant of pi over 4 squared. So we go back to our unit circle again. Secant is flip the x coordinate and cosecant is flip the y coordinate. So if we were to flip over either of these coordinates, I'd have 2 divided by root 2, which I could quickly rationalize, which is 2 root 2 over 2, and the 2's actually cancel. So if I go and substitute this into this question, this will be root 2 squared minus root 2 squared, which is 2 minus 2, which gives me a derivative of 0 at pi over 4. So the slope of the tangent line is 0. Now I can write my equation like we've always done. We can do y minus 2 equals 0 times x minus pi over 4. But because the entire right side of the equation is 0, we'll make the answer y equals 2. And that's your answer. So, in good news, nothing you learned today was brand new. You should be able to do these things and these questions. The answer key is posted. Please make sure you check. Please complete the 3 missing practice problems and hit submit. Then please go complete the 3.5 homework worksheet and hit submit. Have a great weekend.